This video is over topic 32, numbers 7 through 9, looking at compound interest calculations. So compound interest. We already saw annually compounded interest with that general exponential calculation, P being the principal, 1 plus R, so just increasing by that percent rate per year. If it is compounded more than once per year, the interest rate is still the per year rate. The time is still in years. We have to adjust both of those. So the rate gets divided by the number of times per year. The time gets multiplied by the number of times per year. So if it is, let's say, monthly, n equals 12, the rate gets divided by 12 to get the per month rate, and the time gets multiplied by 12 to get the number of months. For weekly, you would use 52. Quarterly would be 4. Annual would be 1, which is why this turns back, like the n just goes away. So you have both of these equations here. This is annual. This is other compounding. N times per year. The ALEKS list only has the one with n, and it tells you on the ALEKS list what n represents. So if you have trouble remembering that, it does give you that little bit more information on the ALEKS list. Again, for compound interest, super important. The only way to find the total interest with compound interest is you first find the future value, subtract the principal. You cannot directly find the total interest. So example number 7, we have an investment of $600 at 5% APR for 10 years. If it's simple interest, the total interest would get calculated first. That would be PRT, so it would be 600 times 0.05 times 10. And that's $300. And then from there, you would go 600 plus 300 and get 900 for the future value. Now, as soon as we get compound interest, it's going to be different. Now it's going to be first you find the future value, and then you use that to find the total interest. For annually, n is 1. The future value is going to be 600 times 1 plus 0.05 to the 10th, or 600 times 1 plus 0.05 over 1 to the 1 times 10, but you don't need to use the 1. So 600 times parentheses 1 plus 0.05 and parentheses to the 10th power, 977.34. And so the interest is 977.34 minus the original 600. And you see, going to annual compounding, you get more interest, $77 or so more than if it was simple interest. Quarterly, compounded quarterly, n is 4. It's going to be 600 times 1 plus 0.05 divided by 4 to the 4 times 10. Probably need to put parentheses depending on your calculator. If you don't have the exponent position, you've got to put parentheses around, or go ahead and do 4 times 10 and use 40. So 600 times parentheses 1 plus 0.05 divided by 4 and parentheses to the parentheses 4 times 10. Again, make sure that you can do this on whatever calculator you are using. It's going to be different depending on the calculator. This comes out 986.17, meaning now the interest, if I take 986.17 minus 600, it is 386.17. So no compounding to annual, added an extra $77, going from once a year to 4 times a year, added another about $9. So it's still going up, but not by as much. Monthly N is 12. 600 times 1 plus 0.05 over 12 to the 12 times 10. 600 times parentheses 1 plus 0.05 divided by 12. Don't do the 0.05 divided by 12 and round that off. Just do it all in one calculation. Any calculator you're using, you should be able to do it all in one calculation. You should not have to stop and write down anything and round it off. If you think you do, talk to me. We'll look at your calculator and figure it out. That comes out 988.21. And so the interest is $388.21, an extra $2-ish from going from quarterly to monthly. Weekly N is 52. Same thing, 600 times 1 plus 0.05 over 52 to the 52 times 10. 600 times parentheses 1 plus 0.05 divided by 52, and parentheses, I'm just going ahead and doing 520 because I can multiply by 10 easily enough in my head, and it saves me the parentheses 988. Okay, rounds to 989 even. So added less than $1 on this. Now going 389 interest. And subtracting the 600 each time to get the interest. Daily, and would be 365. So putting that in, 600 times parentheses 1 plus 0.05 divided by 365, and parentheses to the, again, I'm going to do the multiplication 3650 for the exponent there. And it comes out $989.20. So added another 20 cents extra. So as we increase the number of times compounding, it goes up. So the total interest, let's say this, the total interest goes up, but by smaller and smaller amounts. So we have something like this. It's flattening out. And there's actually a line it's never going to cross. That line is this formula, but we are not going to use that. So we won't ever get to that line. But because of the existence of that line, we'll mostly do quarterly, monthly, weekly. We're not going to keep going higher and higher. Number 8, find the interest on an investment of $75,000 is the principal, pays 4.5%. R is 0.045. Compounded weekly. As soon as I see compounded, I know I'm going to need this formula to get the future value, not the interest. The interest is then going to be that result minus the principal. Compounded weekly means N is 52 for 8 years. There's T. So first finding A is going to be 75,000 times 1 plus 0.045 over 52 to the 52 times 8 power. So 75,000 times parentheses 1 plus 0.045 divided by 52, and parentheses to the parentheses 52 times 8 and parentheses, and it is 107,482.97 that you end up with. You started with 75,000. So the extra that you end up with is the interest. Subtracting the 75,000, it's 32,482.97 total interest. Again, there's no way to get that directly without using the P times 1 plus R over N to the NT. Then number 9, finding the future value of $40,000 investment, 6.9% interest after 25 years, interest compounded annually. You could do n equals 1 or use p times 1 plus r to the t without the n. So 40,000 times 1 plus 0.069 to the 25th power. 1,000 times parentheses 1 plus 0.069 and parentheses to the 25th power. 212, 81, 42. Compounded quarterly, we're going to use n equals 4 then. So 40,000 times 1 plus 0.069 over 4 to the 4 times 25, which is 100. So I'll just use 100 there. 40,000 times parentheses 1 plus 0.069 divided by 4 and parentheses to the 100 power is 221,222 and 78 cents. That's compound interest calculations.